if the triangles are similar, all right? Very key that you understand that. We're finding out if they actually are similar or not. So in this case, it says state how you know they're similar and complete the similarity statement. So let's talk about the three ways that we know triangles are similar, okay? We have three theorems. We have our angle-angle similarity. We have our side-angle-side similarity. And we have our side-side-side similarity, okay? So when you already know all the angles in the shape, you can use angle-angle, but you have to already have two pairs of angles. Not one pair of angles, but two pairs, okay? Now for side-angle-side, that's going to be where you only know the ratio of two sides and you have one angle. If you know one angle, then it can suffice, it's enough, if you have two sides, the ratio of two sides being equal and the included angle between them. That's the key that you guys have to notice. So in this case, we're going to study to see if we could do side-angle-side, okay? Side-side-side is similar, except you're going to have three different fractions, and we're only going to be using sides for this one. So if you look at this, in this case it says KLM. We're talking about this triangle right here. We'll call that the big one. We'll call that the blue one for now. We're trying to see if that's similar to the smaller one that's inside of the bigger one, and we'll call that the red triangle, okay? So what we're trying to find out is, well, do they have any angles that are in common that could help us? Well, look, K is in both triangles, right? So that gives me one pair of angles. So I would usually mark that so that I could know, hey, wait, look, I know for a fact I have one angle, and that might lead me to believe, hey, either I'm going to use this one or this one, okay? And I can't use side-side-side because I don't have the length of this side down here or the length of this one. So I would want to use side-angle-side in this case. I would want to check to see if side-angle-side is actually true. The other thing we have to check is to see if the sides that we have that we're going to compare as corresponding sides, this is 11 would correspond with 44, right? Those sides are corresponding. Now notice that these two sides are making that angle, right? And this side over here, this is 24, the whole thing is 24, and this little piece is 18. A lot of people have been messing up these problems because they'll just use the numbers that are on the page and they're not thinking about what they represent. Okay, in this case, if this is 18 and these two lengths, right, KH and HM, have to add up to 24. So this has to be 6. And I know it looks bigger, but these drawings aren't necessarily drawn to scale. So that's just kind of there, you know, it might be misleading a little bit. Yeah, the 6 looks longer than 18. Well, just deal with it, okay? That's the way it works. So in this case, 6 is the length of this side, and this is 24, okay? So that's what 6 corresponds with, is a 24. So what I want you guys to see is that these two sides, okay, the corresponding sides, we have the 11 and 44, and the 6 and the 24 are making this angle right here, right? Those two sides, I just colored them green, right? And they make that angle, so that's called the included angle, right? So side-angle-side can help us right here. We know that we can do that because I actually have a ratio of corresponding sides that make what we call a congruent included angle, all right, in both of those triangles that we're comparing right now. So what we're going to do is we're going to check to see if 11 over 44, let me change the color there. I don't know if that's going to come up on the video. So if 11 over 44, is it equal? That's why we're putting a question mark. We want to know, is it equal? And we're doing little over big. Notice the inside over the outside one. So this is going to be inside over outside again. 6 over 24. Okay, we're going to check to see if this is equal. But what I see here is this is 1 times 11. And on bottom, we got 4 times 11, right? Over here, we have 6 times 1. And over here, we have 6 times 4. So I can cancel out my 11s, and that would give me 1 over 4. And over here, that would give me 1 over 4. And so basically, we see that 1 over 4 is equal. Notice we're checking to see, are they equal? Are they equal? Hey, look, they're equal. And so since the ratio of corresponding sides is equal, okay, and I know I got 2 of them, that means I got my side and my side, all right? These two sides have an equal corresponding ratio. And since I have that angle, right, and that's the included angle, again, that means that these two sides that I just compared, right, the 11 and 44 and the 6 and 24, they're making this included angle. So I know, in fact, this is side-angle-side, okay? Again, notice that the angle is in between the two sides, okay? So that's going to be key that you guys use that. Now all we have to do is name the triangle. So look, K in KLM is going to be equal to K in K, whatever the other triangles. We're going to find out what the rest of them are, right? We know K is equal to K in those two triangles. Now we have to think about L, Okay, well, L is going to be equal to G. So we put a G here. And then the last one is going to be H. H is equal to M. So it would look like this. Triangle KLM is similar. That's how we read this, that tilde. This says KLM is similar to KGH by side angle side similarity. Okay? And I'm going over this really slow on purpose to try to make sure that you guys see all the pieces that are tied together here. We'll do another example. Okay? Now this example is going to be a lot quicker. Like I said, we have three theorems again, so I'm going to make sure that we think about those three theorems. We have angle, angle, we have side, angle, side, and we have side, side, side. Now let's start thinking about the way that we use these formulas. To use side, 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 or side, angle, side, you need to know something about the side lengths. And I actually don't know anything about them here. There's no numbers to indicate anything to me. I don't even have an isosceles triangle or something that could help me out. That's just not there, okay? So we don't know anything about the sides. But look what we do know about. We know the angles. I know for a fact that this angle matches with that angle. So I would tell you to put an A and circle that so that we know, hey, look, we got one piece of evidence. We got one angle. And then this angle matches with that angle, so that's another pair of angles. And we circle it. Okay, the reason we circle it is so that I don't get like A confused with point A or something like that. We know that this is talking about an angle. So I know I got two A's. And so what that really tells me is that all their angles are equal, right? All three of their angles are equal, because what we studied a while ago was that angle, angle implies angle, angle, angle. I mean, think about it. If this is 20 and it's 30, then this angle has to be 130 so that they can all make 180, right? But then these are equal, right? So that what that means is that if these angles are equal to those, well, then this one has to be 20 also, and this one has to be 30, right? We said that they're equal. So now what would this last angle that's left over, it would also have to be 130, okay? Because they still have to make 180. So you can see that if we have angle, angle in two triangles, right? If two pairs of angles are equal, then the third angle has to be equal also, because they still have to make 180. And if you have the same numbers adding up to 180, you're gonna need the same number to help you do that, all right? So in this case, I would say, yeah, these two triangles are congruent for sure. And they're congruent by angle, angle. So all we got to do is be careful. That's the first thing you might want to write, is actually what theorem are we thinking about, okay? By angle, angle, these two triangles are congruent again, because this angle equals that one, okay? And this angle equals that one up there with the two stripes. So I know that's angle, angle, okay? Those triangles are definitely similar. Again, similar means that the corresponding angles are equal. All of them, all pairs of corresponding angles are equal, okay? And the sides make that equal ratio, okay? Now the weird thing is, in polygons you have to check both of them, but in triangles you only have to check either one, okay? If you know all the angles are true, then we can prove, I haven't done that in this class, but we can prove that if the angles are all corresponding and congruent, then that means that the sides all have a corresponding ratio that's equal, okay? So now all we have to do is label out everything else, okay? And this problem is going to be pretty easy. I know I'm talking a lot to solve this one, okay? But J is clearly equal to C, and K is clearly equal to D. And so that means E is the last one I have to say. So triangle JKL is similar to CDE by angle, angle, okay? Now, this next one is one a lot of people miss if they didn't do too great on parallel lines, or maybe they forgot it. So what you need to do is remember that these lines are parallel. So maybe you can extend them to help you out a little bit, and then we can remember what we knew about parallel lines. So like we had this postulate called the corresponding angle postulate that said that angles like this, like these two, right, they're both on the top left, they're going to be equal to each other, right? So if you look at it, well, look, that gives me one pair of angles that's equal in these two triangles. Let's look at the two triangles to make sure we see what I'm talking about. Okay, we have a blue triangle, and then we have a red triangle right here. Okay, so we're trying to check, hey, is the blue triangle equal to the red triangle? All right? Maybe green will make it look better, all right, because the red's already there. So we got one pair of corresponding angles, and now we have to do another pair of corresponding angles. But if you look over here, this angle, those lines are still parallel, right? Because those arrows show us that the lines are parallel. That's what that red arrow on the picture meant. So I know again that these two angles are equal. Okay, so that's another angle. So that tells me I'm doing angle, angle. So the parallel lines are going to help you figure out that. So now we just label our triangle. Angle A is clearly equal to A, because that's the only angle that's left with no corresponding anything. And plus, it's in both triangles, so you should be able to see that. B is going to be equal to S because they're corresponding, and then T is equal to C because those are also corresponding angles with the parallel lines, right? So just don't forget that the key to the problem was this little arrow right there. That's all it was. If you see that arrow, you should know the lines are parallel, and that means corresponding angles are equal. All right? Cool. So now, we're going to look at this problem, which is an illustration of side-side-side similarity. Okay, in this case, we don't have anything else to help us work but the sides. We don't know anything about the angles, right? So we're going to have to use the sides to help us do this, okay? So what we're going to have to do is make sure that we have corresponding sides. And I like this part because this helps us talk about what corresponding is. Well, the biggest side in this triangle is clearly 126. And the biggest side in this triangle is 56. So guess which ones are corresponding? The two biggest sides are going to correspond with each other. So say I put 56 over 126, okay? We're checking to see if this is equal to the next ratio. And since we have no angles, I actually have to go the long way and check to see if all three of these fractions are going to be equal. What do you think the next side is going to be? Well, if you think about it, the next biggest side is 117. And the next biggest side up here is 52. So that means that 117 is going to correspond with 52. So again, notice I'm writing the littler ones over the bigger one, 56 over 126. So I better write 52 over 117 for this next one. Okay? And now over here on this last one, I'm going to have 54 and 24 are the two last ones corresponding with each other. So I know I'm going to have 24. Again, we're doing the littler sides over the bigger sides, right? Notice that all the sides on top are from the littler triangle, okay? If one of the sides on top is from the little triangle, then all the ones on top got to be from the little one. And notice all the ones from the big side, from the big triangle, are on bottom, okay? So now what we could do is try to chop these up a little bit, all right? Try to break these down into, well, basically any factor that we can find that would be, you know, I'll factor out these numbers until we find their lowest form. That's what I meant to say, the lowest form that we could possibly get from these, all right? So 56 is about 2 times 25 plus 28, right? And on the bottom, we got, well, we could cut this number in half because they're both even. So anytime you see an even number, just cut it in half and take out a 2, and you can move on to the next step and keep going. If it's still even, then keep taking it out, keep taking it out, keep taking it out. All right? So half of 126 is going to be 63. All right, so I know I can cancel the 2's. We might be able to keep factoring this down. Okay, let's look at it. Let's see what else we could get. Well, 28 is 4 times 7, right? And 63 is 9 times 7. So I know I can cancel out my 7's and get 4 9's. And this is definitely in lowest form, right? Because this is 2 times 2, and that's 3 times 3. There's nothing else we could cancel here, right? So we're still trying to check if this is equal to our other fractions, all right? So now, 52 over 117. Well, 52 is 2 times 26, right? And 117, well, that's not even. We're not going to be able to take a 2 out of that, right? So, hey, let's change that. We can't do that. Well, what else can we take out of it? Well, let's see. 52 is going to be 2 times, we said it was 2 times 26, so then it's 4 times 13. So that might lead us to try to take a 13 out of the bottom. But is 13 times anything going to give me 117? Well, 13 times 10 is 130. And then 13 times 9 is, wait a minute, what's 13 times 9? Is that 117? Yeah, 130 minus 13 is 117. So think about it. Well, that means that 13 times 9 is 117, right? So what can I cancel here? I can cancel out my 13s, which means I get 4 over 9 again. So now what we have to look at is this last one, okay? But let's look at it. 24 is 4 times 6, okay? We know that we're hunting for 4's now because we know we want a 4 on top, so that's good. But hey, look, 9 times 6 is 54. So the 6's count out, and look, they're all equal to 4 9ths. So if all of these ratios are equal to 4 9ths, then what does that mean? Are they all equal? They sure are, and we can take away the equal sign because we know they are in fact equal, right? So basically, we know this triangle is going to be similar. These two triangles are going to be similar by side, side, side similarity. Okay, you got to have that little tilde at the end so you guys can recognize that it's not the same side, side, side that we had when we talked about congruent, right? Remember the first side, side, side theorem I taught you meant that the two triangles were exactly the same. In this case, they're not exactly the same. Okay, so now we got to figure out what goes with STU. So let's look, S is across from the biggest side. So which angle over here is across from the biggest side? It's S, isn't it? S is across from 56. So this is going to be S, okay? Now the next side we're going to get is going to be the one across from T. So let's look at T, and we'll say, look, T is across from the smallest side. It's across from 54. So which angle is across from the smallest side? In this case, it's M. So I know this is going to be M, and now that I only have one letter left, I know this is going to be N, okay? So we got S, M, N. Let me write that again. It got a little cluttered, all right? M, N is congruent by side, side, side similarity. Okay, so we had to check all those three ratios to figure that out. So basically, we're moving in the right direction. You guys have seen an example of each one of the theorems. Okay. So again, on this problem, go ahead, pause it, see what you think the answer is. Okay, and if you came back, you should have probably noticed that we can't do side, 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 and we can't do angle, angle. So the only option that we have here is side, angle, side. And you should have seen this is vertical angles, right? So we have one pair of angles. And now look, these two sides that we have are making the included angle, and so are these two. They make the included angle. So we can check to see, is 36 over 60 equal to 36 over 60? Well, clearly it's equal because it's the same thing. So if they're exactly the same thing, they have to be equal. So I know these triangles are similar by side, angle, side. Again, remember the side, angle, side is the one with two fractions. Two S's, two fractions, all right? You can't miss it. And so now if we look at EEC, we know that E is going to be equal to E because we already marked them. And then D could be T or U in this case because they're across some equal sides and there's no way to really differentiate them. So we might as well call it ETU, and that's fine. You could also call it EUT, and if you did that, you would have got it right. Okay? Good work. Let's continue. So number 12, again, on this one, go ahead, pause it and see what you think. And we're back. So hopefully you notice that these lines are parallel. And that's supposed to help us, all right? That's not for nothing. Those arrows mean the lines are parallel. And with parallel lines, we know alternate interior angles are also equal. So I know this angle is equal to that one, right? That's one pair of angles. By vertical angle theorem, I also know that these two angles are equal, so I could mark those with two arcs. And then we say, hey, look, that's another pair of angles. So this is clearly by angle, angle. Again, notice that there was no numbers here on the sides to help us out. We had no numbers to help us figure out anything else, so we must have had to use the parallel lines to figure out some angles. So U is equal to U. But S has one mark, and then up here I think that's P. Let's double check. P has one arc on it too, right? So I know we're going to have U, P, Q. Okay? Notice that Q is the only one that doesn't have a mark, and, oh, sorry, wait, T is the next one, so yeah, the other way around. Sorry about that. It's a bad mistake to make on video. So like we said, U and U both have two marks. So that's U. Okay, again, let me show you my mistake. T has no marks, and Q is the one that has no marks. So that should be Q, and the last one is going to be P. Okay? Sorry about that mistake, but I think we figured it out. So now, we got this problem, okay? Find the missing length. The triangles in each pair are similar. So what it's telling you in this case is that, well, we know these triangles are similar, so which side is bigger? Well, if we know they're similar, then it's kind of easy to see that, okay, well, 22 times what is going to give me 11? That's 22 times 2, right? So what number times 2 is going to give me 16? I mean, that's one way to look at it. That would be 8, okay? But another way to do it would be put an x right there, and then you could write 22 over 11 equals x over 16, right? Or I did that backwards, right? Again, notice that I started with 22 on top, and that was from down here. So what should have gone on top is another one from down here, which is 16. So I'm going to get 16 over x, okay? So in this case, we get 22x equals 16 times 11, right? Like I said, we cross multiply. Okay, 16 times 11, that's 160 plus 16, so that's 176. All right, and if I divide both sides by 22, I'm going to get x equals 8. All right? So that's the way that one works out a little bit, okay? Sometimes you got to be a little clever because we could have matched up 16 with 11, which would have maybe made sense, okay? So what I probably should have done was put some angles in here with some numbers so that we would know what would really be the corresponding sides, okay? So this problem is actually a little ambiguous. All right, go ahead, pause the video, and try number 14 and see if you can figure this out. And we're back. So I hope you guys figured out that what we want to do here is use our little numbers and our big numbers to help us figure this out, okay? I know that 26 over x, okay, since these triangles are similar, right? I know the little over big must be equal to little over big. So again, that's 18 over 27. Okay? You got me? We're trying to see that these two ratios, these two proportions, this proportion, this equation has to be true because the triangles are similar. Okay? So now what we do is cross multiply again. All right? And if you do that, you should get 18x equals 26 times 27. Okay? And if you solve this problem correctly, the video is dragging on, and I don't mean for it to do that. I'll just pop up the video. The answer should be 39. Okay? So you should have got 39 for this ratio down here. All right? Cool. I also noticed some people do these problems like this. They started factoring the numbers right away, and they looked at it like, hey, wait, look, this is 2 times 9, and this is 3 times 9. And they were like, hey, wait a minute. What's going on? First, this thing got doubled. This number 9 got doubled, and now it's getting tripled. So they were like, wait a minute. Look, this is 2 times 13. And if this is 2 times 9 and then 3 times 9, when this is 2 times 13, excuse me, then this is going to be 3 times 13. And 3 times 13 is 39. Okay? Notice that I didn't have to do any complicated proportions or anything. It just kind of squeezed itself out by noticing the factors of the sides of the triangles that we had here. So that's another way to do these problems. All right? This problem over here, there's a lot of ways to do this one. I had taught you guys one way that was